Okay, significant figures in calculations. You take your measured numbers that you recorded very carefully and you plug them into your calculator, adding, dividing, multiplying, and your calculator will often give you a whole bunch of digits. We need the answer to the calculation to reflect the uncertainty in that number. And so we have to follow some rules, and we use significant figures to help us keep track of that. Now, a lot of students do not like significant figures, but the alternative is differential calculus. Anybody want to do that instead? I don't. I learned differential calculus, but I forgot that as soon as I finished the class because I didn't need it anymore. So this is actually easier. If you can learn how to play Monopoly, you can learn how to do sig figs. It just takes a little time. So sometimes we have calculations with multiple steps. What we want to do there is to only round the final answer. We don't want to round off each individual step because that can introduce error into your measurements. So when you multiply and divide, this is how we deal with the significant figures. Your answer is going to have the same number of significant figures as the factor with the fewest significant figures. So in these examples, here we have 5.02 times 89.665 times 0.10 equals, your calculator will give you something like that. Well, does that mean that this result has uncertainty way out here? Probably not. So the rules for significant figures say what we need to do is we need to look at each of these numbers and identify how many significant figures are in that number. So 5.02, how many sig figs? 3. 89.665 has 5 sig figs. 0.10, 2. The leading 0 doesn't count, but the trailing 0 does. So then, this is the easy part. Which number is smallest? 3, 5, or 2? 2. So that's how many digits there should be in our answer. So we're going to keep the 4 and the 5. Now, as sort of a shorthand to keep track of things, I underline the last significant figure. That's the uncertain digit. What that means is we're going to round this number to the ones place, and we're going to get rid of those digits. When we're rounding a number, this is the place we want to keep. We look at the next decimal place. If it's under 5, we just knock those digits off. If it's 5 or greater, we round up. So in this case, the next digit is 0, and so we're going to report this answer as 45. Any questions? Let's look at the next example. 5.892 divided by 6.10. Your calculator is going to give you something like this. So we're going to look at this first number. How many sig figs does it have? 4. And 6.10 has how many? 3. Which is smaller, 6 or 3? I mean 4 or 3? 3. This is the smallest. So then in this number, there really should be a 0 here. That 0 just calls attention to the decimal point. That's not a significant figure. We're going to keep 3 digits, 9, 6, and 5. So I'm going to underline that one. That's the last significant figure. I look at the next digit to see if I need to round up or round down. Well, I need to round up. So that's going to change that 5 into a 6. So 0.966. Because this number is closer to 0.966 than it is to 0.965. So we don't want to just chop those off. We have to round it up to 0.966. Any questions? So when we're rounding, you only look at the first digit that's being dropped. You don't look at anything after that. Sometimes students get a number like this. They're tempted to start at the end and, oh, I'll round this up to a 4, and that 6, and this rounds up to, and they'll go all the way back through there. At best, it's going to waste your time and effort. At worst, it's going to have you round the number incorrectly. So don't do that. You're just looking at the first digit that's going to get dropped. If it's 4 or less, you round down. If it's 5 or more, you round up. And I look first and last. Your book talks about the last digit, which just doesn't make sense to me. So if the first digit that's being dropped, I have to fix this slide. If the first digit that's getting dropped is 4 or less, you round down. If it's 5 or greater, you round up. So 2.33, if we're rounding to 2 significant figures, we're going to keep this tenths place. We look at this 3, that's less than 5, so we round this down to 2.3. 2.37, rounding to 2 sig figs. The 7 means we have to round this up to 2.4. Any questions? So let's do some practice. You should always bring your calculator with you to class. Some days we'll use it, some days we won't, but just bring it with you anyway. So to do this number, the first thing we want to do is we just want to type all of this into the calculator and then write down everything the calculator says. So I've got 1.10 times 0.512 times 1.301 times 0.005 divided by 3.4 equals, and my calculator gives me a mess, as it so often does. Now I sometimes make mistakes, so if I do this wrong, you need to correct me. I'm getting 0.001077534. I make mistakes all the time. Did I do that okay? Anybody else get that? Okay. That's the first thing. Now we need to figure out how many significant figures should we have in the answer. And we do that by looking at how many sig figs are in each of these numbers. So for now, we're still practicing. Once you get good at this, you can just kind of look at it and see which one is the smallest. But we're going to evaluate each of them. So 1.10, how many sig figs? 3. Trailing 0 is significant because of the decimal point. 0.512, 3. That leading 0, never significant, so it's just the non-zero digits. How about 1.301? 4. That 0 is trapped in between, it counts. How about 0.005? Just 1 sig fig. All of those leading zeros don't count. We just got the 5. And then 3.4, 2. So which of those has the smallest number of significant figures? 1 is the smallest. So our answer needs to be rounded to 1 significant figure. So I'm going to start from left to right, and I'm going to go until I hit the first non-zero digit, because none of those leading zeros are significant. So it's this guy. I'm only keeping 1. That is the uncertain digit. And then for rounding, I'm going to look at the next place. Well, that's 0. That's easy. I round down. And so we're going to record this answer as 0.001. Any questions? Let's do this next one. 4.562 times 3.9987 divided by 89.5 equals. So just use your calculator and then write down what it says. 0.203822.004. Anybody else get that? Well, lack of protest I'll take as agreement. We need to figure out which of these has the smallest number of significant figures. How many does the first one have? 4. How many does the second one have? 6. Do you actually have to count them all? Not really. You can look at that and say, well, that's more than 4. So we could just not worry about that one. And this one has 3. So my answer should have 3 significant figures. So I don't count that 0. We got the 2, the 0, and the 3. This decimal place is my last significant figure. I look at the next digit to decide whether I round up or down. So I'm going to round this up, and I'm going to express this as 0.204. Any questions? It is a very good habit to write down the whole answer that your calculator gives you, or at least write down more than the necessary number of significant figures, and then round the answer. The advantage to this is if you realize that you rounded too much, you still have the original answer there, and you can go back and fix it. You don't actually have to do the calculation over again. So adding and subtracting. So adding and subtracting, here the answer has the same number of decimal places as the quantity carrying the fewest decimal places. So with multiplication and division, it was number of sig figs. Here it's number of decimal places. So let's look at these. So here, the numbers are stacked up like we would do if we were doing long addition without a calculator. In 5.74, which of those digits is uncertain? The 4. I'm going to underline that. In 0.823, which digit is uncertain? The 3. It's always the last one. So in 2.651, which one's uncertain? The 1. So when you do the adding, you could do this in your head. My experience is people make mistakes when they do that. So if you want to practice that somewhere else, you go right ahead. We've got calculators. We're going to use them. Because it's dumb to add in your head and get a complicated problem wrong because you did some simple math wrong. So I'm going to add these up. And my calculator tells me 9.214. Yeah, I think I did that right. So let's think about this. If we're adding this without the calculator, we would start on the far right and we would add the 3 plus the 1 and we'd get 4. Now, there's uncertainty in the 3, there's uncertainty in the 1. So what does that mean about the 4? It's uncertain. Okay, so that digit is uncertain. And then in the next column, we've got a 4, a 2, and a 5. Those add up to 11. We carry the 1. So there's uncertainty in the 4. So what does that do to this 1? Makes it uncertain. Because if you've got certain numbers and you're adding something that's uncertain, it makes the result uncertain. So this 1 is also uncertain. So in the next column, I've got the carried 1. I've got the 1. I've got a 7, an 8, and a 6. I'm certain about all of those. That adds up to, must be 22. How about this 2? Am I certain about that? Yeah. And everything to the left of this, there's no uncertainty. So this is how we come about this rule here. When we're adding these up, there's uncertainty in all of these places where one of the numbers has uncertainty. So when this is our final answer, significant figures are the certain digits and the first uncertain digit. So that means we're going to keep the 1, but we're going to ditch the 4. So we're going to record this as 9.21. There's uncertainty in that 1 in the hundredths place. Another way to think about this, stacking these up, and think about going from left to right and looking at the columns. No uncertainty in this column, no uncertainty in this column. This is the first column that has uncertainty. So after the first column, I'm going to draw a vertical line. I'm going to include the first column that has uncertainty. That's where my answer is going to end. It's another way to think of it. So these are the more understanding methods of thinking of it. Here's just the flat out rule. You're going to count decimal places. So this one has 2 decimal places, 3 decimal places, 3 decimal places. The smallest is 2 decimal places, so my answer is going to have 2 decimal places. The difference is with multiplication and division, it's number of significant figures. Adding and subtracting, it's number of decimal places. So in this one, how many decimal places should the answer have?
1.
Just 1. Because this one has 1 decimal place. This has 3 decimal places. This one only has 1. So we do the math. 4.8 minus 3.965. Helps if I push the right button. 4.8 minus 3.965. Calculator says 0.835. It should have 1 decimal place. So we record this as 0.8. Any questions?
And if it was let's say the 3 was like a 7, then you would round up as well?
Yeah, if this next digit was 5 or 7 or 9, then we'd have to round the 8 up. But because it's less than 5, we round down. Because this 0.835 is closer to 0.8 than it is to 0.9. And that's all rounding is it's finding which is the closest number. Any other questions? So we can end up with the answer having different numbers of significant figures than the initial quantities. And this actually is an example of this. This number had 2 sig figs, this had 4, and the answer only has 1. That happens very easily in adding and subtracting. So in this example, 28.02 minus 27.99, how many decimal places should the answer have?
2.
Should have 2 decimal places. When I do this on my calculator shows me 0.03. Well, that's 2 decimal places. So that's correct. I don't even have to worry about rounding it. But this had 1 significant figure, and each of these had 4. But that easily happens with adding and subtracting. You can end up with much fewer sig figs or many more sig figs. Just depends. It's decimal places for adding and subtracting. Okay, so let's do these examples. So we're going to add these together, and we're going to get an answer. Well, we're not going to add them. We're going to do the stated operations because there's a subtraction in there. So 2.18 plus 5.621 plus 1.587 minus 1.8. 7.588 is what my calculator tells me. So I write that down. Here I have adding and subtracting, and so I'm going to look at number of decimal places. How many decimal places does the first one have? 2. And the second one? 3 decimal places. And the third one, sorry. This one. It's got 4. And the last one. Just 1 decimal place. Adding, subtracting, counting decimal places. So the smallest number of decimal places is 1, and so my answer should have 1 decimal place. The next digit is 8, so we round this to 7.6. Questions? Let's do this one. 7.876 minus 0.56 plus 123.792. Calculator says 131.108. Which of these numbers has the fewest number of decimal places? The 0.56, it has 2 decimal places. This one has 3, this one has 3. So I need to round this to 2 decimal places. So that's right there. So 131.11. Any questions? Well, it's easier if you just have adding, subtracting, or multiplying and dividing, but sometimes you get a combination of them in a single calculation. So you need to follow the rules for order of operations. Do steps in parentheses first. You need to figure out the correct number of significant figures in the intermediate answers without rounding them. Just make a note of it. Finish all the steps, and then round the final answer. So this is a little more involved. Let's do some examples. So here we've got 3.897 times the quantity 782.3 minus 451.88. So we want to do the steps in parentheses. If you don't remember about orders of operations, please excuse my dear Aunt Sally PEMDAS. You always do things in parentheses first. So I'm going to do the thing in the parentheses first, 782.3 minus 451.88. I press equals. When you first start with this, as we're all first starting right now, I encourage you to write that number down. So 330.42 is what the calculator tells me. Now I'm going to use that underline notation to indicate where the sig figs end. So this was subtracting. The rule is fewest number of decimal places. This has 1 decimal place. This has 2 decimal places. So if I was going to be done here, I would round this to 1 decimal place. I'm not done yet, though. So I'm not going to round. I'm going to leave it alone. But I'm just going to make a note to myself, that one ends in the 1st decimal place. Then I take this number times that number and get my result. So times 3.897. And my calculator gives me this big mass. 64674. So now what we're going to do is we're going to look at, this is multiplying. We took this number and multiplied by this number. Well, now we're looking at number of significant figures. How many significant figures in 3.897? 4. And in this number, we underlined the last significant figure so that we can count sig figs. So 1, 2, 3, 4. If we were done there, we would have dropped the 2. This number has 4 significant figures because of where it came from. So they both have 4, so my answer should have 4. So the 1, the 2, the 8, and the 7, there's 4 significant figures. So then I say that rounds to 1288. Yes?
When you're multiplying, let's say like the 330.42, as far as with the multiplication, do you still multiply with the 2 in there? Or
Yes. Yeah. You want to include the 2. You don't want to round it off yet. Because sometimes if you round off, this is called an intermediate value. If you round that, it can affect the final answer. It won't affect it much, but it can mess it up. Yeah. Any other questions? So let's do this one. So here we have 4.58 divided by 1.239. That quantity minus this. So we want to look at the result of this division and then do the subtraction. So 4.58 divided by 1.239. So my calculator gives me 3.696529,459. Ugh. It's obviously way too many sig figs. Dividing, the rule is number of significant figures. So this one has 3 sig figs, this one has 4 sig figs. That means that the result should have 3 significant figures. We're going to make a note of it, but we're not going to round the number. So 3 significant figures would end right there. I still have that number sitting in my calculator. I don't have to type it in again. I just wrote this down so I can make a note of where the last significant figure is. And then I'm going to subtract 0.578 and write down what my calculator tells me. 3.118529,459. It's a lot of digits. This number came from subtracting. We take this number minus that number. So when we're doing a subtraction, we look at number of decimal places. So this number, if we had rounded it, would have 2 decimal places, right? We underlined the second decimal place. And this would have 3. So that means this number should be rounded to the second decimal place. This is right there. And so that would round to 3.12. Any questions? This is something you need to practice to get the hang of.